Okay, this is homework help 4.5 number 8. We're going to read it together. We need to predict the flight path of a toy, the predicted flight path of a toy rocket. So we've got a toy rocket. I like to draw pictures. Here's my toy rocket. It's got a predicted flight path defined by a quadratic relation where d is the horizontal distance and h is the height. So it's doing something like this. Except I know that a parabola should be symmetrical. So it probably looks a little bit more like that. And we're given the function that defines this relationship. We're told that h, which is the vertical height, relates to the horizontal distance based on this quadratic relation given in factored form. -2 times d minus 3 times d minus 15. A. Sketch a graph of the path of the rocket. Well, let's do that one first. We'll do it over here. You're probably using graph paper. I know that this thing is going to be above the ground, so I'm not going to go too far there. I also know I don't need to worry too much about my negative x-axis because I just look at this equation and I know my x-intercepts. So, can someone please help me in finding my x-intercepts just by looking at this equation? Let's go with hands so everyone gets a chance to think about it for a second. Lindsay, can you give me one of them? One of them is +3. X equals 3. Isaiah, the other one?
15.
X equals 15. So if I'm going to sketch a graph of this thing, all I need to know right now is that I have one x-intercept at x equals 3, and I have one x-intercept at x equals 15. Well, what else would be helpful in sketching the graph of this equation? Knowing where the vertex is. Okay? So I use the same old strategy when I'm finding my vertex as we've done before. I'm only going to find, for the vertex, I can find the x coordinate by taking the mean of my x-intercepts. So 3 plus 15 is 18, divided by 2, x equals 9. So I know that my vertex is somewhere along this line, right where x equals 9. But I don't know exactly how tall it is yet. How do I figure out how tall this thing is? How high the rocket goes?
Plug the x coordinate back into the equation.
Good. In this case, I'm working with d and h, and I should actually note that on my graph, that d is the independent variable and h is the dependent variable. And this function tells me exactly how h will change with respect to d. So all I need to do, I'm going to slide my board up. It's not really convenient, but all I need to do is find out what happens to h when d is 9. So everywhere I see d, I'm going to sub in 9. And then according to my order of operations, BEDMAS, I'm going to do some algebra on this. Inside the first bracket, 9 minus 3 is? Second bracket, 9 minus 15 is? -6. So here we have 6 times -6, that's -36, times -2. So 36 times 2 is 72. Negative times a negative is a positive. Looking at positive 72. Okay, I didn't draw a scale for my h's. If you were going one block for each unit, 72 would be way off the page.
Whoa.
So I'm just sketching it, so I can really make my scale whatever I want it to be. I can say, okay, just underneath my dot here is 70. Doesn't look like just underneath from your perspective. And then I can split these in half, say that's 35, and then I can just go 10, 20, 30, 40, 50, 60. It's just a sketch, right? All I'm showing is that my vertex is at, what's the point of my vertex? What are the coordinates? 972. And that means when the rocket has progressed a distance of 9 meters well, it's actually only progressing 6 meters forward because it's taking off from the point 3. But when it's at a horizontal distance of 9, it's at a vertical distance, a vertical height of 72 meters. And now I can finish out my sketch by drawing a rounded, symmetrical parabola. Application question. Does this parabola go forever and ever and ever?
No.
No, why not?
Because it lands.
Because it's an actual real-world situation where we're looking at a rocket. It starts somewhere and it's going to hit the ground somewhere. Good. So it has restrictions to its range. B. How far from the wall is the rocket when it lands on the ground?
9 meters.
How far from the wall
15.
is the rocket when it lands on the ground? 15 meters. C. What is the maximum height of the rocket? 72 meters. How far horizontally is it from the wall at that moment?
9 meters.
9 meters. Okay, simple sketch. All we had to do was calculate our vertex, the x-coordinate of our vertex, sub that in to find the y-coordinate or the h-coordinate, and then answer the questions that it asked.